Welcome to INSITECT. Today we are talking about fire alarm solutions for shopping malls and retail complexes. We're diving into what is, arguably one of the most complex areas in facility management. It's this intersection of life safety, massive security needs, and really sophisticated architecture.
It really is.
Our mission today is to analyze why fire detection in a shopping mall is so much more than just, a simple smoke detector on the ceiling. We're looking at sources that treat this as a continuous, really complex management challenge.
That's the perfect way to frame it.
Yeah.
Because you're dealing with extraordinarily high stakes here. Think about it. Thousands of visitors, staff, huge inventories, all concentrated in one place.
Right.
The margin for error is, well, it's zero.
Right.
The goal isn't just an alert. It's about achieving surgical precision, rapid detection, and a notification system that is coordinated across the entire complex down to the second.
Okay, so let's unpack that initial risk. What makes the fire risk in a big retail center so different from, say, a standard office building?
It's the diversity of the fuel and, really, the conflict built right into the design. An office is predictable. A mall is just a mosaic of different hazards.
How so?
You have concentrated heat sources right next to fuel, the food courts, for instance. You've got intense cooking, grease fires.
And they're just yards away from a clothing store.
Exactly. A clothing store full of highly flammable merchandise or furniture or books. It's all right there together.
And we probably don't even think about the infrastructure that's running everything behind the scenes.
We don't. And the back-of-house areas are inherently high risk. That's where you find all the cardboard, the packaging, a huge fire load.
Plus the electrical systems.
Constant massive electrical loads. Thousands of lights, signs, HVAC units. The electrical panels themselves are a prime ignition source. And then for the big anchor tenants, you might have refrigeration or high bay racking, which introduces a whole different kind of vertical fire risk.
But it sounds like the architecture is the real enemy here. Those beautiful, huge open atriums must just turn into chimneys.
Instantly. It's the single biggest challenge. Those grand multi-story atriums that, define the mall experience. For a fire engineer, they are immediate vertical and horizontal smoke pathways. So a small fire in one shop can fill the entire facility with smoke in minutes. It can affect zones far away and cut off escape routes long before the actual flames get anywhere close.
So with that kind of risk, what are the mandated legal baselines? What forces engineers to actually solve these problems?
Well, the sources cite some critical regulations. If you're designing in the U.S., you have to comply with NFPA 72. That's the big one.
Okay.
In Europe, it's the EN 54 series of standards. And these are not guidelines. They dictate the absolute minimum technical response required to protect people.
And how does that translate into the evacuation plan itself?
Because of the high occupancy, the codes often mandate two critical things: integration with sprinklers and, crucially, the use of phased evacuation.
Phased evacuation, so you're not telling everyone to run for the doors at once.
Exactly. The strategy is to prevent mass panic and, dangerous crushes at the exits by moving people out of the immediate danger zone first, then the adjacent zones.
That sounds great in theory, but with dozens of different tenants, security teams, staff, how do you make sure the human element doesn't just fail?
That's where the system's intelligence and a lot of training come in. The system is designed to allow trained staff, like security, to investigate an initial alarm before it escalates to a full-blown evacuation.
So it's not just about life safety, it's also about business continuity.
It's a dual goal. Life safety is always number one. But the secondary goal is protecting the property and reducing that downtime. The faster and more accurately the system can direct the fire service, the less damage occurs, which protects the owner's long-term asset value.
Let's shift to the tech. If a fire starts in some remote corner of a 3-story mall, how does the system know exactly where it is and what to do? Why can't you just use a simple conventional alarm?
Because a conventional system would just be a shot in the dark. It might say, fire, 3rd floor east wing, which could be 20 different shops. It's useless.
Right.
In a big multi-tenant site like this, you absolutely have to have an addressable system. That's the game changer. It identifies the exact location of every single component.
So it gives security a street address for the fire, basically.
Precisely. And that granularity, that saves everything in those first few critical minutes. It speeds up fault diagnosis and allows for that granular control. And for the really huge centers, you'll see a distributed architecture.
Meaning multiple panels all talking to each other.
Yes, multiple local panels linked over a network, all reporting back to a central fire alarm control panel, the FACP, which is usually in a dedicated fire command center.
In that command center, what are the non-negotiables for the FACP itself?
Reliability, above all else. It has to be in a secure location, have a dedicated tower supply, and a really robust battery backup.
Yeah.
Has to keep working, even if the main power is cut by the fire.
Okay, let me play devil's advocate here for a second on the false alarm problem.
Go for it.
Malls are chaotic. You've got steam from coffee shops, dust from a store being refitted, cooking fumes from a kiosk. How on earth do engineers stop this thing from going off every 10 minutes and disrupting business?
That is probably the biggest operational challenge. And it really comes down to using the right tool for the right job. You can't just put a generic smoke sensor everywhere.
So what's the strategy?
For the big common corridors and public malls, you typically use optical smoke detectors. They're pretty good with smoldering fires, but less prone to false alarms from a bit of dust or steam.
And what if a small shop is right next to, say, a pizza place?
Good question. Inside those shops, especially near food outlets, you'd use multi-sensor detectors. They combine smoke and heat detection and use smart algorithms to check if both are present before triggering.
Ah, so it's looking for confirmation?
It's filtering out the nuisance triggers. And in the actual kitchens where a smoke detector would be useless, they're replaced entirely with specialized heat detectors or even flame detectors.
What about a place like a cinema? It's high occupancy, dark. You can't just blast an alarm and flashing lights in there.
Right, you'd risk a stampede. Cinemas often use what's called high-sensitivity smoke detection, or HSSD. These systems are constantly sampling the air, and they can detect tiny combustion particles long before you'd ever see smoke.
Giving staff a pre-warning.
Precious minutes to investigate quietly, without panicking the audience.
So we've detected the fire precisely. Now, how do we tell thousands of people what to do in a loud, confusing environment without causing the panic we're trying to avoid?
Simple bells or sounders just cause confusion. People don't know what to do. That's why voice evacuation speakers, or PIVA systems, are so critical and often mandated.
Because they give clear instructions.
Clear, intelligible instructions. Attention, a situation has been detected. Please wait for instructions. It reduces confusion and makes that phased evacuation possible. And of course, these systems have to be supplemented with bright, visible strobes for the hearing impaired.
Zoning seems to be the key to managing this whole response. How do you create that logical structure?
The zoning is the blueprint for the entire evacuation strategy. You start with the common areas, the atriums, the main walkways, as your primary zones.
And then the individual stores.
The individual shops become subzones. This is where that targeted response happens. An alarm in one unit can trigger a local alert first, giving staff time to investigate before it escalates to a building-wide alarm.
And the big anchor tenants, the department stores.
They often operate as their own independent zones, sometimes with their own sub-panels that just interface with the main mall system for coordination.
Let's dig into a high-risk zone like a food court. We've all seen a small grease fire or someone burning popcorn. How do you stop that from shutting down the whole mall?
It's all about isolation. The food court has to be zoned for a localized alarm. The system is designed to allow for local warnings and suppression, like a kitchen hood system activating, without triggering an immediate full mall evacuation.
What about the unseen spaces, like the service corridors and parking garages? They must have huge fire loads.
They're absolutely critical. Multi-level car parks are a unique challenge because of all the exhaust fumes. So engineers use specialized car park smoke detectors or heat detectors calibrated to ignore that.
And the loading docks.
Huge fire load there, with all the packaging and pallets. A fire there can take out vital infrastructure. So those service areas, including electrical rooms, must have robust coverage and be separately addressable in the FACP, so facility teams know exactly where to go.
It's clear the FACP is more than just a sensor panel. It's like the conductor of an orchestra. What are the key automatic actions it triggers?
It kicks off a whole chain reaction. First is evacuation control. It plays those pre-recorded voice evacuation messages and manages which zones hear which message as part of the phased evacuation.
And it controls movement.
Immediately, it triggers elevator recall, sending them to a designated recall floor and taking them out of service. Escalators are usually stopped as well.
But the most critical part has to be controlling the smoke, which you said is the real killer.
Absolutely. It takes active control of the mechanical systems. It will activate smoke, extract fans in the fire zone, use pressurization fans to push clean air into stairwells and escape routes, and open automatic smoke vents.
So it's actively fighting the smoke migration.
That's the concept. By pushing clean air into the escape paths, it creates a positive pressure barrier that literally holds the smoke back, keeping those routes tenable for people trying to get out.
That level of control means the FACP has to talk to every other system in the building. How does it communicate with, say, security and the building management system?
Deep integration is non-negotiable now. The FACP talks to security, so the moment an alarm goes off, CCTV cameras can automatically pan to that exact location.
For visual verification.
Right. And at the same time, the access control system gets a command to unlock fire doors and turnstiles to make sure egress is clear.
And the BMS.
It'll get a command to shut down the main HVC systems to stop them from circulating smoke all over the building. This all happens using open protocols like BANet or Modbus, which let all the building's smart devices speak the same language.
We've covered the design complexity, but a brilliant system is useless if it's not maintained. What's the required rigor for keeping a system this complex reliable?
The schedule is intense, and it's dictated by code. This is not a set-it-and-forget-it system.
Yeah.
You're required to do documented weekly functional tests rotating through different zones.
Okay.
Then you have monthly tests on the batteries and backup power. And every year, a full, comprehensive annual commissioning test, which includes simulating alarms and even testing the PAVA system's intelligibility. And it all has to be recorded in a logbook.
Let's go back to the false alarm problem. Beyond just choosing the right detector, what are the best practices for stopping that disruption?
A lot of it starts with tenant education. Staff need to know not to block detectors. But from a system perspective, programming is key. We can use investigation delays or confirmation logic.
Meaning it needs two signals before it goes into full alarm.
Exactly. A smoke detector and a heat detector, for example. It gives security that small window to verify if it's a real emergency. We're also seeing facilities use analytics now to spot patterns and proactively clean or replace detectors that repeatedly cause minor issues.
So if you had to synthesize everything we've talked about, what's the single most important lesson here?
That life safety in a place like this is a continuous dynamic management process. It is not a one-time installation.
Because the mall is always changing.
Always. Tenants move in, they move out, walls get shifted. Configuration control is absolutely vital. Every time something changes, the system needs reprogramming, and the as-built drawings have to be updated. That continuous management is what makes the difference between an orderly evacuation and a disaster.
That dynamic nature is fascinating. We've established these systems generate immense data faults, environmental changes, alarm patterns. Right now, it's used for passive maintenance, but imagine how that real-time feed could evolve into proactive risk modeling.
Right.
Facility managers could potentially predict the areas of highest fire risk based on patterns of system faults combined with, say, changing tenant layouts or even mapping system stress against peak foot traffic density.
Yeah.
You'd be shifting safety management from just reactive compliance to truly predictive safety. That's something substantial for you to mull over.
It paints a clear future for life safety technology.
Thanks for listening. We will continue to talk about security and technology. See you in the next episode.